Question number 26. You're given the derivative. You want to find the function with this point. So we're doing the antiderivative. So in order to understand the antiderivative, this one has a hook. Look inside the parentheses. The derivative of 3x is 3, and then we need 1/3 what it was over what it became to keep them equivalent. We circle it and unhook, and then our answer starts with 1/3. The antiderivative of cosine is sine, and then of course the constant at the end. Now we have a point to plug in, so we have pi over 6. Oops, here go 1/3 sine 3 times pi over 6, and make it equal to 2. We need to know a little bit of simplifying. 3 goes into 6 twice, so this is really sine pi over 2. I like giving myself a visual of where pi over 2 is. It's at the top, and sine goes with the y coordinate at the top. So 1/3 times 1 is 1/3. So subtract 1/3, and you have what c equals. You can think of this as 1 2/3, or you can think of it as 5 over 3. Come back here. We have our answer. Number 27, obviously you should press pause, write down the question, and press play. The derivative and integration, they undo each other, so what's left is your answer. So it's always best. Again, press pause, write it down. Do your best first, then press play. Acceleration is the derivative of velocity. There is a little hook in here. To go back the other way, I need to integrate this. I wonder what the best way to integrate that is. Is it to do a hook? Probably, right? Yeah. All right. So to integrate this, the hook again is 1/3, but I want to undo that hook to unhook it, what it was over what it became. Or if I multiply it times 3, 3 times 1/3, it would equal what it is before. Then you can unhook this. Are we given a point too? We are given a point. I'm going to run out of space here, but it's okay. So we're going to add 1 to the exponent and divide. Notice the 3's divide out, so you have 1/3 t minus 1 cubed plus c. Now we plug in the point. I'm going to do that here on the left. So the point is at position at time 0 is 4. So in other words, when you plug in 0, the answer should be 4. I'm going to do that right here. So when you plug in 0, the answer should be 4. 0 is great. -1 cubed is -1. So if I add 1 to the other side, c is equal to 5. So if I put this all together, I'm going to do that right here. You would have 1/3 t subtract 1 cubed plus 5. So there's the position equation. There's the acceleration. And we could also write that as 2/3. And then there's the velocity. Part C says, when is it resting? So I need to know which equation gives me resting. That's velocity. So if you take the velocity equal to 0, that will tell me when it's resting. So look inside the parentheses. What makes that 0? You can add 1 and divide by 1/3, or make it equal to 0 and solve it. But when you do that, the answer is +3. That's what would make it, because 1/3 times 3 is 1, and 1 take away 1 is 0. So 3 is what makes it 0. That's when it's resting. And then it says, when is it moving up? So we need a number line just for 3 for the velocity. into the velocity, if I plug in like 0, the answer is positive. If I plug in a number anyways, it's squared. So any number I plug in is going to be positive. So it's moving up from negative infinity to positive infinity. It means it's always moving up. Except at 3 where it's resting. When does speed equal velocity? And the answer is because the velocity is always positive, they're always equal. The only time they're not equal is when velocity is negative, because speed is always a positive value. So since velocity is always positive, speed always equals velocity. Part F, total distance. Because the particle does not change direction at all, we can just plug in to find the total distance. So just plug in 9, and you would plug it into here to get your answer. That's 3. 9, 1/3 of 9 is 3. 3 take away 1 is 2. 2 cubed is 8. 8 plus 5 is 13. You would also plug in 3. 1/3 of 3 is 1. 1 take away 1 is 0. So that just leaves me with 5. And then you'd subtract those two answers, and the total distance it went is 8. When is speed increasing? So speed is increasing. We have to look at acceleration. So because velocity is always positive, speed is increasing when the signs match. All right. So if I look at velocity again, what number makes it 0 is positive 3. If I plug in 0, I get a negative answer, and when I plug in like 4 or 5 or 6, I get a positive answer. So from 3 to infinity, this is the acceleration number line. From 3 to infinity, acceleration's positive and velocity is positive. So when the signs match, speed is increasing. So from 3 to infinity, it is increasing. Good question. All right, number 29, you should press pause and write it down and do your best first. Then press play. In number 29, you're asked to find tangent and normal lines. So I already have it set up. And so I'm going to write this as 3x subtract 5 to the 1/2. If I plug in 2 for x, 3 times 2 is 6, take away 5 is 1, and the square root of 1 is 1. To find the slope, I need to find the derivative. So the derivative is 1/2, 3x subtract 5, subtract 1 to the exponent, and don't forget the hook. And then I plug in 2 into here. And again, so what's the derivative at 2? Gives me the slope. 3 times 2 is 6. Take away 5 is 1. 1 to anything is 1. So it ends up being 1/2 times 3, which is 3 over 2. So the tangent line would be y equals 3 over 2, x minus 2 plus 1. The normal line, you would do the opposite reciprocal. So it'd be negative 2/3. That's the perpendicular. Everything else would stay the same. That's the word normal. So you have the tangent line and the normal line. Number 30, 31, and 32 are all connected. So in 30, what's the instantaneous rate of change here? First of all, you should press pause. You should try it first, right? Write it down, then press play. To take the derivative here is the quotient rule. That's the bottom. And whenever you think, oh, that's what it is, press pause and then you try it still. The more you do it independently, it's way more powerful. So do the quotient rule. I am going to simplify this. So t times 1 is t, and negative t, they cross out. So when I simplify the numerator, you're just left with 1. You should try it. If you distribute and combine like terms, you're left with 1. You can do that. And then when I plug in, what's the instantaneous rate of change at 1? You'd plug in 1 for t. 1 plus 1 is 2. 2 squared is 4. So the instantaneous rate of change is 1/4. For 31, you're supposed to find the AROC. You should press pause and try to find the average rate of change. To find that, it is f at 2 minus f at 0 over 2 take away 0. So I'm going to plug 2 in. That's 1/3. I'm going to plug in 0. That's 0. And so 1/3 divided by 2 is 1/6. Oh, did I do something wrong? Let me try again. Oh, the numerator is, I thought that was a 1 for a second, sorry. You plug in 2 into both. That's 2 over 3. So that when I do this, it's 2 over 6, or 1/3. All right, got it, as I looked at the answer key. And then in, actually 33 is also connected, sorry, 32, which of the slopes is a secant line? So a secant line is AROC when you use 2 points and find the slope between 2 points. So the secant line, the slope is 1/3. And this is, how about the tangent line? Which one is that? That's the derivative we did in 30. So the secant line is 1/3, and the tangent line is 1/4. In number 33, this is the mean value theorem. When does AROC equal IROC? Between 0 and 2. So there's a discontinuity at -1, but -1 is not between 0 and 2, so it works. And we already did most of the work. So the derivative is 1 over t plus 1 squared. The AROC, which we already found from 0 to 2, is 1/3. Notice the numerators equal each other, so we can make the denominators equal to each other and then solve that. So I need to square root and subtract 1. Now, the answer could be positive or negative here, but we want positive root 3 because that's between 0 and 2, not the -1. So the exact answer is root 3 subtract 1. That's what I'm looking for. At that moment, AROC equals IROC. Negative root 3 subtract 1 would not be in my interval. 34, please write it down. Please press pause, try your best, and then I'll do it. So I need to take the derivative here. That's 4x, 2y, but it needs a hook because we're doing it implicitly, and then 4, but it needs a hook. The y primes need to be together, so I'm going to subtract 2y, y prime here. Oops, this is 4y prime. Minus 2y, y prime. I'm going to factor out the y prime. And I have 4 minus 2y. And then I'm going to divide. So I'm going to rearrange this. So 4x is in the numerator and 4 minus 2y is in the denominator. If I simplify it, divide everything by 2, this is what I get. 2x over 2 minus y. Next, to find the horizontal tangents, it's the numerator. It's when the slope is 0. So when x equals 0, it is, do I need to find the points at that one? Yeah, find the points. So if I take the numerator equal to 0, I can see it's when x equals 0 is when the whole slope is 0. Go back into the equation to find the y coordinate. So plug in 0 for x and then solve for y. So this is a quadratic. I'm going to subtract 4y and make it equal to 0. Factor out a y. And so I get two answers here, 0 and positive 4. So at 0, 0 and 0, 4, at both of those points we have horizontal tangents. For vertical tangents, it's the denominator. It's what makes it undefined. So the denominator. So a vertical line, the slope is undefined. That's the denominator equal to 0. That makes it undefined. So when I solve this, y is equal to positive 2. And then I go back into the equation to solve for x. So I plug in positive 2 for y. And then I solve it. So 2 squared is 4. 4 times 2 is 8. So it's 8 subtract 4. Divide by 2. Now I square root it. And so you get the answer positive and negative root 2. So at positive and negative root 2, 2, we have vertical tangents there. Number 35, write it down, and you need to do your best first. And then as you press play, once you are understanding it better, you should still press pause and try to be as independent as you can. This is a linearization question where we use the tangent line to estimate. So to find the tangent line, the x and the y are right there. We need to find the derivative to find the slope of the line. So that's 3x squared minus 3. Plug in 2 into the derivative to find the slope. 2 squared times 3, that's 12. Take away 3, which is 9. So the tangent line's 9x minus 2 plus 7. Next, we're going to plug in 2.1 into that line and then simplify it. So 2.1 take away 2 is 0.1. Oops. 9 times 0.1 is 0.9. Add, and you get 7.9. Number 36. Here it is. Press pause, and then try it. So here's the derivative. I want to do a number line. The only number I see here, there are no x-intercepts for it for here. So there's nowhere where the derivative is equal to 0, but it is undefined at 0. And then what I look at, is it above or below? So for both, it's above. So this whole function is increasing. But at 0, it's undefined. For the second derivative, same thing. 0 is undefined. And there's no turning points. But this is increasing, and then on the other side, it's decreasing. So the concavity is here. And then when I go here to my graph, at 0, it's undefined. So I'm going to do undefined at 0. And then we have a point at -1 and +1. And we have a, right? Sorry, -1 and +1, and then 1 and -1, like that. And so what we know is on both sides it's increasing. And it's concave up and then concave down. So on both sides it's increasing and concave up. It's increasing and concave down, and it matches it. 37. I'm just going to answer this right on the book, but you need to write it down. So what's the limit as x approaches -2? Let me zoom out here so that I can do it in one step. So what's the limit as x approaches -2? So from the left and from the right, it's approaching 2. This is not for the limit, so the limit is 2. What's the limit as x approaches 2? From the left and right, the y value is -2. So we're looking for the y value that it's approaching. At 3, there's an asymptote, so it doesn't exist. We could also say it's -infinity. -4 from the left. So here's -4 from the left. -4 from the right. So from the right, the y coordinate's 0. So I couldn't see it from the other way. I'm not going in order, right? I'm going down the column. I should be doing like this here. So these are the function values here on the right. So f at -2 equals 3. You're looking for the closed point. F at 2 equals -2. F at 3 doesn't exist because there's an asymptote. And f at -4 doesn't exist because it's a hole. All right, the last one. Last one is use the alternate form of a limit definition to find this. That was like 100 years ago. So let's do that together. It's okay that you forgot. That's what we need to practice. So let's do it together. I know you need help. So my goal is to find the derivative at 2 using the limit definition, the alternate one, to do that. So I need to know the limit as x approaches 2. In the numerator, we have the function, which is x squared plus 1, subtract, and then you plug 2 in, and 2 squared is 4 plus 1, which is 5. And then in the denominator is going to be x subtract whatever we're approaching. So there's the setup. So I'm going to simplify. I'm going to hopefully factor. So that's a difference of squares. And then we remove the discontinuity. So we can remove x minus 2. And then you can substitute in and see the answer is 4. All right. I'm so proud of you. Doing your work, doing your best. I'm doing my best. Mr. G Math, over and out. Until next time.